Hey guys, welcome to this new tutorial in Grasshopper. In the last tutorial we were looking at the expressions to calculate the centroid point of a face, right? So we were doing a math expression here by adding these 4 points and dividing them by 4, right? So that's what we had, and we're going to just see a little bit more of that in this one. So let's talk a little bit about how do we calculate the normal face. Like pictorially, first we're going to do it with just nodes, and then we're going to do it with expression, right? So let's get a vector between 2 points. So we're going to create a vector between, so let's think that we're kind of going to start in this point, and we're going to create this vector in this direction and that vector in that direction, right? So let's make a vector from there to here. So that's our first vector. And I'm going to create this one, and I'm going to create one from here to here, right? So that's the second one. When you want to visualize the vectors, I mean, the vectors are not going to be visible unless you do a vector display, right? So you could just do vector display. Here we go. Right, so the vector display will allow us to visualize this vector. So we can put the vector here, and the anchor point, maybe we want to use this point, which is going to be our pivot. So you can see now that we have that vector there. And if we display this other vector, that's the other vector, right? So you see that we have this arrow and that arrow, right? If you're new to vectors, just check those first vector tutorials that I have before jumping into this stuff. So that's good. We have a vector display there. Let's remove it, and let's do a cross vector now. So the cross product between two vectors, between this vector and this vector. Oh, I should have kept the, so I'm going to call it again, so vector display. So the anchor again, this guy, and let's visualize this. So you see that the vector of the cross product, what it's doing basically is creating the perpendicular between these two, right? So we have that vector there. So that's pretty good. That's what we want. At this point, maybe the anchor that we want is the centroid that we calculated before, right? So the one part of the calculation was the centroid, and that's to actually put the, so that's kind of the normal of the face, right? Well, considering that this is a kind of a planar face, I mean, a quad, as you must know, might not necessarily be a coplanar, right? The 4 points don't need to be, if this point is living in like somewhere here, this face will have basically, you could consider 2 triangles, and each one of them would have a different normal, or there would be like a curvature. So that wouldn't be the case. This calculation would be useful only if you have a planar face, right? So maybe this vector is kind of too long. One thing that we could do is unitize it, so unit vector. So I could connect this vector here, and then if I put it there, you can see that my small vector here, the normal vector, it's located in the centroid, right? So that's pretty good. But we could do all this again, all this stuff within our expression, right? So let's create a new expression, and let's do it from scratch. So I feel a bit rusty on this, so maybe I'll struggle with math of it, but let's see if we can do it, right? So I'm gonna do what I did before. We're gonna do 4 variables. Actually, in this case, we just need 3, right? So I'm gonna connect X. So these are the 3 points, right? So if we go here, a lot of this stuff, I mean, I hardly use it, but like some of these are kind of useful, right? So you could actually do a cross product here, right? So for instance, what is this, the vector 2 that we have here? So we know that x, it's our one of the points, and if we do x minus y, that would be one vector, right? This vector 2 point is the same as the subtraction of two vectors, right? So we're gonna say the cross product of that with the cross product of x minus z, right? So that, let's see what we get out of that, right? So at this point, let's visualize this vector, and you see it is, yeah, it's working. So basically I can tell because I just plugged this into the vector display and it's showing me the same vector, right? So in this case what we're doing is the subtraction of one vector with the cross product of the subtraction of the other vector, right? So this is like, at the beginning when I saw this screen for the first time, it was really scary, like there's a lot of kind of things going on, and it's not literally kind of programming, but it's just, you know, math operations, but really powerful. So how do we unitize it? You see that you have the unit vector here, unitized. So if we just put these square brackets here to everything, I think, yeah, there we go, right? So again, we simplified all this into that node, right? Into this node here, where we just subtracted the points and make the cross vector out of that. So if you start getting used to these kind of operations, you might make it much easier for you to kind of simplify your networks and have like shorter nodes, right? So we can just get rid of all that. I mean, you can keep it if you want, but that's kind of the quicker version of it. So yeah, with this kind of little node, we could just go through the faces and find normal. And yeah, it's interesting that here we're getting them inside some cases. Yeah. So the calculation, depending on the operands, like if you kind of change the the order of some of these, you might get the arrow going in or going out, right? So you just need to make sure that it's working for your face. But yeah, we're gonna leave it here for this one. We're doing this calculation because I'm interested in understanding how geometry would, how we could orient, let's say, another copy of this geometry, aligning them in the face, and how, yeah, what are the pivot points in which, and the normals to describe that kind of orientation, right? So this is it for the second expression tutorial. I'll see you guys soon.